go about that. I put in my slides, I've tended to start putting this little comment is that why can't we just open the windows? Gord Cook and I were having a talk. Gord's a big consultant. He's based out of Canada, but why can't we just open the windows? Well, we can. I mean, that is something we can do, but there's some reasons we don't that we'll see in presentation. And we are froze. What do we do here?
If all else fails, there we go. We're good.
There we go. What we'll cover is, for one, I wanted to be sure. I love this little picture of this truck hauling this air conditioning unit, and really has nothing to do with ventilation, but it just shows the wherewithal that many of your HVAC contractors have to get the job done. And I don't know the results of this pickup and delivery, but we hope everything went well. We'll cover in the presentation what is mechanical ventilation. There's different ways to describe it. We'll go through one. We hear a lot about ASHRAE and ASHRAE 62.2. Short explanation of what that is. Quite honestly, I thought I knew a little bit more than I did, and then joined and learned, and then joined and found this off the website. 62.2 formula. We'll look at 2010, 2013 chart. We're not going to spend a lot of time on it. Just we'll look at that and some of the differences in it. Why can't we just, again, comment, why can't we just open the window? Some of the challenges when we do use that as our ventilation strategy. We'll do air leakage and testing, obviously blower door duct blaster. The IECC 2015 code, we'll cover that. 2018 is out, but not everyone or not many has adopted that. So we're going to stay with the 2015 in this session. A question, one slide on why are they not ventilating? There's reasons, some good, not some a little weak, but we'll go over that. There's a Florida study that was done with the Florida Energy Solar Energy Group, University of Central Florida, that did a small study, but some of the results are very interesting, and we'll go over some of those as what people are doing for after they have exhaust installed, or a house they buy that has it, and what condition it is in whenever they came in and tested and verified what's there in the operation of it. What are my choices? As Jason said, exhaust supply balanced, strengths and weaknesses of each. I didn't cover all of them, but what I thought was, or what I believe to be the major ones. Just a few pictures of installations and some of the challenges associated with that, especially in tight houses, and the ventilation and how they're vented, and some of the results. And again, last is kind of wrap it up, what's the right thing to do? Mechanical ventilation systems bring in fresh air and remove stale air using ducts and fans, either independent or combined, rather than relying on airflow through open windows, small holes, cracks, and just passive ducts. That's mechanical. Energy efficient home construction, as builders construct more energy efficient homes, as demonstrated in the pictures. Dirty air is trapped inside. This requires effective and efficient ventilation. I use the word effective a lot. You won't necessarily see it in the presentation a lot, or maybe much more, but effective is what it has to do. You can put things in, but it has to work. It has to effectively work with the house as a system to ventilate. ASHRAE, American Society of Heating, Refrigeration, Air Conditioning Engineers. Global Society Advancing Human Well-Being through Sustainable Technology for Building Environment. The society and its members focus on building systems, energy efficiency, indoor air quality, refrigeration, and sustainability within the industry. And it merged with Society of Refrigerating Engineers in '59 to become ASHRAE with the R. And another important thing is that ASHRAE is a standard. Now, as a standard, it's commonly used as baseline for building codes and programs, but it's a standard, not a code. It's not confusing, but sometimes you hear, well, ASHRAE code. Well, it's a standard that helps develop code, drive code, give code the reasons to do some of the things they do, but it is still a standard. The 62.2 committee was formed in 1996. The 62.1 committee was all there was at that time, and it was for commercial. So in 96, the 62.2 committee was formed, and obviously it's been maintained by ASHRAE more than 20 years. It's reviewed and revised every 3 years by ASHRAE, as depicted in the picture showing that, hang on, there's going to be changes. The two charts. Okay. Excuse me. 62.2 2010, that's 7.5 CFM plus number of bedrooms plus 7.5. And then you have 1 CFM per 100 square feet. Example, 3,000 square foot house, 4 bedroom, 30 CFM plus 30, 60. The 2013 is 3 CFM per 100 square feet instead of 1. And though there is an infiltration credit that can be taken based on the actual home tightness after testing, which can be a challenge because as a contractor or as someone who designs the ventilation requirements, is that it's not necessarily an unknown, but it can change, it can vary. Worst case scenario would be twice as much ventilation using that same example. But we find end results are that it's pretty similar, but it does take that testing, and you can change that, but depending on what system you have, that may not be as easy as you would like for it to be. All right, why can't we just open the window? Isn't that beautiful view? Nice beach, palm trees, window open, nice breeze. Problem is that airtight design doesn't allow for natural ventilation of harmful pollutants within the space. Like humidity. Humidity is a pollutant. Opening the windows for effective natural ventilation relies on wind and stack effect. It works best in climates with cool, dry nights and consistent breeze. Wind may not have enough velocity to move through the space because of simply wind direction. How the house is built or the direction of it and location of the windows. Air is unmanaged in quality and quality. It pushes and it pulls, but what kind of air is it? The drawing at the bottom was done by an engineer who had questions about his personal home, did some testing. You see how that air comes from the right to the left and then goes over the roof, and then probably see some of it along the side, but you see what type of reaction that structure has when that air ends up on the bottom side. I use the example of when you see the trucks go down the road and the trailers have that fin on the back that opens up the top and bottom and side. They're trying to disrupt what's happening. For an example, or shown on this house, is that air does a lot of very disruptive things on the back side. So you have that air, you think that, boy, if I have a breeze, then I have good ventilation or I have good air around my house. That is not always necessarily true, because you do have that push and pull and reaction on the building. Natural ventilation. Okay, you open the lower windows, you have the air come in, but what you have is that air will rise up. The floor camera, I found this picture. It may not be a great depiction of what's happening going on, because that roof could be actually where you have heat going through the ceiling, through fixtures and all, but that is still heat rising. in almost all cases is that it's coming up, it's not coming down into the roof. The stack effect with unconditioned air entering on the first floor rises and exits the upper floor, windows, skylights, fixtures, holes, or even a whole house attic ventilation fan. You need an exit path, or it will sit at the ceiling or upper walls as hot, depending on what region you're in, humid air. This will create a comfort issue and possibly a microbial growth problem. And that is a very nice way of saying mold. Natural ventilation, indoor pollutants. Stale air is contaminated daily by pollutants like cooking, cleaning, odor-reducing products, new building materials, preservatives in furniture and carpet, and of course the trapped moisture. Okay, which window will the homeowners open and how long to reduce or remove these contaminants? What impact will it have on the HVAC system, which is now right-sized, which typically means smaller tonnage? It doesn't have that extra half ton or even ton of cooling, 12,000 BTUs capacity, nominal capacity, to overcome these window openings or these events that happen that can have the house lose its comfort. What happens with the window when it's hot and humid? I know our dehumidifier friends always ask the question, sure, air conditioning does dehumidification as one of its results, its products that are things that it does, but what if it's 70 degrees and it's raining? Not a lot of dehumidification going on. Okay, when it's raining, the homeowners will likely close the windows and then receive their ventilation through, again, opening and closing of exterior doors through normal traffic, or your spot ventilation with bathroom, laundry fans, and kitchen hoods, which are all exhaust strategy, which creates a negative pressure. So you're going to be pulling that moist air through your cracks and crevices. This slide is found interesting just in doing some reading about natural ventilation, outdoor pollutants, talking about the Clean Air Act requiring the EPA to set National Ambient Air Quality Standards, NAAQS, for 6 common air pollutants. There's a lot of other pollutants out there. These are the ones they chose, and this is really for information. Ground level ozone, particulate matter, which comes in different PM 2.5, as what you see as in kitchens, carbon monoxide, lead, sulfur dioxide, and nitrogen dioxide. And this is direct quote, they can harm your health, environment, and property. And that's off the EPA government criteria air pollutant www site. All right, 2 ways to do whole house and duct system leakage to verify, to test. 2 must be done, whole house pressure test. I've listed some climates. I know that some changes had been made, some allowances. I just put up there what the requirements are. Different regions have different ones. If you're Florida, it's going to be different. I know Alabama, I've done code training out there. I know that there's different ones for their region. In fact, they actually had 3 climate zones at one time. They got rid of one of them just because it was confusing for everyone. But I think the important part of this shows where we were and where we are now in our air exchange requirements, how much tighter houses are. I get a lot of questions about ventilation and, what you've designed, what you make, that's good for foam houses. Well, absolutely, but also if you've got a house that's 3 ACH 50, that is an extremely tight house. It needs effective ventilation. It doesn't ventilate on its own very well or not at all. And then the second form is the duct system leakage test, which as a former HVAC contractor, begrudgingly we were drug into using mastic because it added cost, but it actually helped reduce our CFM requirements in our HVAC systems. Then of course our tonnage, our tonnages. So it has been an effective way to not only when you change the house itself, but also when you seal up the ducts. It makes a huge difference on comfort and, of course, delivery of the air and the return of the air. We've all seen the blower door, or if you haven't, that used to be actually a door, a hard door that would somehow be mounted. It was not very easy, and now it's obviously a canvas, but the premise is the same. We're going to draw air through the house. Once it's typically complete, it has to have the sweeps and everything sealed to effectively measure, because you'll have too much leakage. One thing that I found in our testing, and again being in the industry, is that if the contractor does not seal the supply and return air boots and the exhaust fans to the ceiling, just putting the grill on and just having the boot tight it still leaks. So it is very important and can cause failure of the test, or the house to fail. So that's another important piece that sits up there at the top of the ceiling that a lot of times we don't look at, but if you go back, it's a huge factor. All right, where's our major source of air leaks? 31% is floor walls and ceiling. There's a lot of floor walls and ceiling in a building, in a structure, in a house. So if 31%, then that's where the major source of it is. That's where we really have to look at the house itself, critically those items. But those are the most things that we have. So there is good opportunity for that to not get sealed properly. Fireplaces is 14%. That and obviously the sealing of it, the drafts don't close well. So you're gonna have, that's just technically it's a big hole. Your plumbing penetrations, and the plumbing gets blamed for this 13%. I'm sorry, ducts are 15%. Plumbing is 13%, but that includes all penetrations. Every time you make a hole, you create an opportunity for leakage. Then you have doors. Doors are inherently leak just from the fact of door sweeps and how their framing is and gasketed to seal up, and then windows, same thing. There's a lot of manufacturers and the way that windows that are installed, that they get a lot of blame for things, and in many cases it's the installation of those and not the product itself. And then you got the electrical outlets that aren't sealed good that can have leakage. I included the flare pictures kind of related to that last chart, to where you can see where some of the communication is. This is an upstairs bonus room, and you can see where some misalignment of insulation is, but also that's going to create that communication with the outdoors, with the outside. They just didn't get their insulation at the top really to effective. It's not an effective installation. It looks like they missed some insulation on the left with the here on this one panel that you would never see because it's covered with sheetrock. And then on your connections here, on your duct where it's connected there's obviously leaks. That could also be moisture at some point. That's on a long trunk line, and then the ducts are coming off. You see the fireplace, that's not sealed properly behind it. I'm not even looking at the actual fireplace itself, but there is a huge opportunity there to have a comfort problem because that's not insulated. And this is an outside penetration, if I'm not mistaken, related to fresh air for a fireplace, where you have a sealed combustion, and you see that we've got some issues here where it isn't sealed. Duct blaster test. That's a really poor picture. That's one of the best ones I could find. But obviously we use the same, well, that's a DG, probably that one's a 700, maybe not 1,000, but we pressurize the duct system or depressurize, and then you test it to see what the leakage is. If you use it with the air handler, you get a little more allowed leakage, but your air handler furnace is one of your greatest sources of leakage. The manufacturers say that there's leaks 2% or less. I'm just not sure what their percentage is based on. I've discussed that with them before, and I don't really get a good answer out of it. Okay, common ductwork problems. You see the leaky duct connections, return air leaks. Both of those look can cause major problems with the actual performance of the system. If your ducts are leaky, let's say on the supply side where they come out, if you have a duct come off, then you're going to lose all your velocity and your pressurization through the other ducts, because it's going to take that direction, that path, because I describe these in supply air as mad air. It's trying to get out. It's trying to go somewhere. You have a fan driving it, forcing it, to leave. Your return air that's coming in is lazy air. Again, my description. It's half the velocity, almost half the velocity as the supply air. And it's it doesn't care where it gets its air. If there's a big duct there, absolutely I'm going to take the air from there. So it doesn't tend to draw equally from the different duct on the box on the plenum, but also what you have on the supply side. Let's go back. What you have on the supply side is that in distribution, you tend to have a little better distribution out of the supply whenever you pressurize that box, that you can have different size duct. It isn't always equal, but you do have a little better distribution. On the return side, again, it doesn't care where it gets its air, and we'll address that as one reason. One of the ways to bring in fresh air is not as effective as sometimes described. The furniture blocking is for upflows through the floor out of a basement. Again, you have the leaking at the furnace, filter slot. You can have fallen duct insulation within the unit. Again, supply leaks, and then kinks in the ductwork. All right, code. We're going to go over code real quickly. Right as a news release was, Governor Greg Abbott signed House Bill 1736, adopted the 2015 IECC. The requirement identified as mandatory in the IECC 2015 Chapter 4 shall be met. Excuse me again. The Chapter 4 is mechanical ventilation. The ICC decided, which I thought was smart of them, instead of writing it themselves, it says to follow the International Residential Code or the International Mechanical Code, which addresses ventilation. Outdoor air intake and exhaust shall have automatic or gravity dampers that close when the ventilation system is not operating. Whole house mechanical ventilation system fans to meet the fan efficiency requirement, table 403.6. And one thing that was in the code, well, it's still in the code, but it's being voted on now to be taken out of the code, is the little sentence that says exception, when the fans are integral to tested and listed HVAC equipment powered by an ECM motor. When that first came out, that was interpreted a lot of different ways. One way was, I don't have to do anything if I have an ECM motor on my HVAC system. I don't have to do anything. I don't have to put anything in, because that's what I have. That's not what it means. It means that you can use that method of the central integrated fan to bring in the air if you have an ECM motor. But the one part that is clear that it's not stated, that I state, is that you still have to meet the CFM of fresh air requirements that's in the IMC table 403.3 or the IRC table 1507.3.1. In other words, you still have to bring in the prescribed amount of air, either by the chart or by the formula, but you're not exempt. And there's our 403.6.1. I think Jason alluded to that. That's actually been increased. That'll come out in 2021, that the fan efficiency requirements of the inline fans will be 3.8. But you see that ERVs or HRVs, they were not fortunate, but they're allowed to be less efficient. So 1.2 CFM per watt, that means the amount of CFM that comes out is to a wattage ratio. And again, efficiency is what we're looking for in the way of delivering more air out of whatever it is, or exhausting more air out for less energy used. All right, the IRC addresses exhaust systems. We're not going to talk about clothes dryers, even though it's really interesting how that actually has an effect and applies to a house as a system, because that right there can be your largest exhaust fan in the house. And in a very tight house, that can have some repercussions or effects on the performance of it and also of the dryer. But we're just going to do range hoods. Range hoods are becoming much, much more important to the whole house and to the house as a system. We have trapped moisture, we have trapped pollutants, and we need to effectively get those out of the house through a ducted hood, vent-a-hood, microwave. I don't like that application. I don't think they work very well, but something is better than nothing. But the code reads that duct serving the hood shall have a smooth interior surface, and we'll see one here in a minute that doesn't have that, but I'll give the reason why. It needs to be airtight and equipped with a backdraft damper, independent of all exhaust systems. It shall not terminate in the attic or crawl space. And then you have the exception, manufacturer's instructions, where mechanical or natural ventilation is otherwise provided. Listed and labeled ductless range hoods shall not be required to discharge outdoors. Makeup air requirements. This has become a bigger issue because you see a lot of really big hoods going in because people have bigger stoves. They think they need a bigger hood, but in some cases it's more the capture efficiency of the hood than it is actually the CFM. But we'll talk about that at another time. But code says anything that will draw out more than 400 CFM, cubic feet per minute, must be provided with makeup air at a rate approximately equal to that exhaust rate, the additional rate. You don't have to have the 400 you get. It's the next 400 or 200 or 1,000 potentially that you have to have a properly sized, designed makeup air. What you see is a lot of duct with a damper on it that's located in a relative location to the kitchen. They used to be like in a laundry room, which doesn't work because you're not cooking in a laundry room. The 1503.4.1 location was added in the last code cycle, which says it has to discharge in the same room in which the exhaust system is located, or in a room or ducted system that communicates through one or more permanent openings. In other words, you can't have a door that closes. If you got a cased opening and you put it in a hallway right outside the kitchen, that does qualify as the approved location. But another part of the house with a door that closes, that is not approved. Mechanical ventilation, general, when a local exhaust or whole house mechanical ventilation is provided, the equipment shall be designed in accordance with this section. Exhaust air can't recirculate it, has to be exhausted directly to the outdoors. House mechanical ventilation has to meet the requirements of 1507.3.1 through 3.3. 3.1, mechanical ventilation consists of one or more supply or exhaust or combination. Local exhaust and supply are permitted to serve as a system. Outdoor ducts connected to the return side of the air handler shall be considered as providing supply ventilation. Mechanical ventilation, the second one is that the ventilation rate. You can have a percentage runtime, and the reason it's not the reason I put it up here, but you have to understand if you use that strategy, then you're running a fan intermittently, and it's on either a controller, a timer, or just something that is determined to be published as smart. But if you reduce down to, let's say, half, so if you need 60 CFM of ventilation, continuous ventilation, and you're going to set that to run half the time, then you need 50% more when it does run. So that means you need 120 CFM. That isn't always what happens. Put an example down here, 2,000 square foot, 2-bedroom, again, the 60 CFM. If you run the timer at 25%, multiply that times 4, that's 240 CFM under the intermittent operation. In other words, you're gonna need to have a fan that delivers 240 CFM during that ventilation runtime, which is difficult to do consistently. All right, the IRC, their chart is the 2010 ASHRAE chart. No difference, same numbers, same chart, just as something to know. International Mechanical Code, it's got requirements. They want balanced. We won't go over the whole thing, but you see chart 403.3, that's been there through at least 3 code cycles and hasn't changed. And when we're talking about the ventilation requirements for the house, theirs is 15 CFM per person. You go, oh my gosh, now this is different than the IRC, so which one are they under? Well, if you do the math, when it says that it's based on number of bedrooms, first bedroom 2, each additional bedroom's 1, is that if we do the 3-bedroom, which is people, then you do that, that's 3-bedroom, that's +1, that's 4. 4 times 15 is 60. So you have the same. So don't get hung up on that, oh my gosh, or me get hung up on it maybe. The IMC 2015 chart and table, and then you have the IRC. It's very close, it's very similar to each other. All right, why are they not ventilating? Well, one, it's cost. It costs more. If you're in Lubbock and you're just putting a 6-inch duct, that's much. It costs less than to put something in, even the duct and damper. So if they get by, then I don't think that's an effective way to do it, but you do see that. The home energy rating system index impact, depending on how you look at it, it can have it can have a negative impact on your HER score. You have humidity. If it's not managed properly, you can have the buckling of the wood floors. You can have comfort complaints, temperature complaints. You're pulling in all this hot air 24/7. Labor, did they get it right? Did they install it correctly? Did they get the right training to put it in right? And that includes wiring it, which we find some that the easiest way to not wire it wrong is to not wire it at all. Then you have red tags and then construction delays. There's nothing that makes the builder more upset than to have a delay at the end of construction because of something related to ventilation. It leaves a real bad taste in their mouth. Indoor quality. Is it filtered? Are you effectively bringing it in to where it doesn't have a negative impact on the air quality? And the client themselves, I think sometimes we forget it's their home. They can do what they want to with it. They can turn it off. They can have it removed. We certainly don't recommend it. And then building code, again, as Jason said a while ago, may not require it at all. Sometimes it's vague, sometimes it's minimal, and sometimes it's not enforced at all. All right, here's the Florida study. It's a little busy slide, but really on the Florida Solar Energy Center, this was in 2015, and the title was Investigation of Effectiveness and Failure of Whole House Mechanical Ventilation Systems in Florida. This is available on their website, or you can Google that name of it, and you'll have the whole report. It's pretty lengthy, it's detailed, it's really good. It's a good read, I thought it was, and information. All right, 21 houses, 3 types of ventilation systems: exhaust fan or ERVs, runtime ventilation with electronic controls, runtime ventilation without electronic controls. Test results: 9 of the 21 were not operating. 3 of the 21, that's 14%, had ventilation airflows close to design levels. 2 were turned off by the homeowner, admittingly turned off by the homeowner. So only 1 out of 21, 4.8%, delivered design levels, actually delivered it. Again, the 3 out of 21 were close, but actually there were only 1 that actually delivered 4.8% of the whole number of houses, delivered design levels. Only 12 of the 21 were found to be capable of operating, and that's the lower half. All right, ventilation methods. We have 3: exhaust, supply, and balanced. Exhaust, pretty easy as a product description: bath exhaust, kitchen exhaust. Supply, what we had for many years until, not that I came up with a crazy idea, but I had one that we apply now, is mostly central fans, central integrated fans, systems like the Honeywell, April Air's got one that I installed thousands of, and then inline fans where you just bring in air, different ways to do that. And then balanced ventilation, typically you would describe as an ERV or HRV, or a combination of exhaust and supply. Spot ventilation. Now, when you hear spot ventilation, we talk about is that's a 50 CFM fan or a 100 CFM kitchen exhaust. All right, exhaust strengths. Cheap. You can use Energy Star rated fans. They're efficient with the right fan. Easy to install, see them in every house. Good source control for indoor pollutants in kitchen, out of your kitchen and baths, and can be used to be compliant, to meet your compliance with standard 62.2. Given the proper size and weakness, no control over where the fresh air comes from. And I mean the air, when it's exhausted, where is that replacement air coming from? You really don't have control over that. And that means that you can have potential infiltration of outdoor pollutants into the space because you're pulling in wherever it can get air. It's not making any determinations or choices other than where can I get it? You really likely has insufficient fresh air rates in tighter homes. Sometimes they don't perform well at all because, again, for a tight house, and it's a real poor choice for hot and humid climates because of drawing that humidity in through your cracks and crevices and doors uncontrolled. Kitchen hoods, exhaust hood vent strengths, varied models and related cost, energy efficient with the right fan, easy installation operation, good source control for indoor pollutants in the kitchen, and can be used for compliance with standard 62.2, given the proper size and brand model of the hood that's designed to meet the ASHRAE 62.2, which Air King actually has a really good one that does that, who I know real well. Weakness, higher cost. Depending on what your model is, most of your, not saying most, many of your new home construction, you see the combination microwave, vent-a-hood. Really the people that make those and sell them are microwave people. So the venting part of it is not their primary source of why they're doing it. But it does meet requirements. You change that, you got different cabinets, you got a lot of things that happen, but they make really good microwaves. You need makeup air, went over 400 CFM as a weakness. How do you effectively vent it? I mean, if it's going to be a hard venting, then you reduce the effectiveness of the product. And who installs it properly? You don't want it falling off the wall, which is be bad, fall on someone or people or on your food. Poor choice for hot and humid climates. Again, you're negatively, the house is under a negative, potentially a lot of times are, especially with your higher CFM hood and your microwave fan combo or less effective for ventilating. All right, the central fan integrated system. This is what, there are thousands and thousands of those out there. You have a motorized damper in most cases. This is depicted with manual or motorized. It's ducted into here, into your return, pulls in here. You have this one shows an air cycler. It's a brand name. It can be just through the thermostat. It can be another brand that says, okay, I have not run long enough as a system with this open. So what I'm going to do is I'm going to bring this fan on, this big fan. I'm going to open this damper and I'm going to magically pull in a certain amount of air, 60 CFM, we'll keep using that. And then when I've ran it for this period of time that my control says it needs to, because it hasn't run as a heating or cooling system long enough, comes on. Very inefficient way to do it. You got this big fan trying to pull this little bit of air in here. Your return is saying, okay, I'm going to get my air from here under the big arrow. The little arrow, it's not smart enough to say, I need this amount of air. It's low cost, widely used application, can reduce infiltration from uncontrolled sources. It really is poor air delivery, higher labor cost, wiring and commissioning, make sure it gets set up right, higher operating costs because you're running a large furnace or air handler to bring in a small amount of fresh air. You can still have potential humidity and temperature concerns. And then the intermittent running of the fan and furnace can irritate residents. I received calls in one of the companies that I managed the new construction division, that homeowners were very upset that their fan was running and my thermostat is off. Supply, independent fan, very ineffective but effective way of bringing in fresh air. You have a powered fan. It's ducted. This one shows it's ducted to 2 different locations. Can be cost effective. It can be applied to multiple zones. It's noisy. Location of the ducts and fresh air outlet is key to comfort, and there's no way to temper the outdoor air coming in if you don't have any controls. You have another supply independent fan application, which I really like, that you limit the intake of hot and humid air, cold, dry air. You positively pressure. It has an internal CFM dial, timer, and sensor. It's very quiet. It's 0.4 to 1.6 zones, which is sound level. Your most efficient exhaust fans, you see many manufacturers make those that are, but they'll be 0.3. So this unit on its lowest setting is 0.4, which is 40 CFM, up to 120 CFM. It's independent. You don't have to wire it with anything within the thermostat or the air handler or furnace controls. There's no low voltage, 120 volts, 4-step programming. It does have an internal slot for a 10 by 10 by 2 filter that can be sourced up to MERV 16. And your weaknesses are it costs more. It is not the cheapest nor the most expensive, but it's certainly not the cheapest solution. And there is no tempering of the outdoor or the incoming air. What we do with that is that we limit the amount of air. In other words, when it gets outside the settings that this sensor senses, it will cycle the fan off and it turns on a timer. And we're continually to sample and ventilate until it gets back within the settings, and then it runs continuous. It's a pretty good design. And what we have here is an example of how a system can be set up. This is showing it coming in through the eave or through the soffit vent. The machine in this application, fresh air machine, is right prior to the return air of the unit. Goes in through the air handler, exits out the supply, and then it is picked up by the return, and obviously back to the unit. So that is how the system can work. All right, balanced. Hear a lot about ERVs and HRVs. Strengths, they are energy efficient per the manufacturer. No home pressurization issues, problems. You can have quality air distribution, mitigates temperature and may some humidity. Weakness is a higher cost of all the solutions. Requires regular filter maintenance. You've got to do that because if the core gets dirty, then that's the heart of the unit, and you just now have a fan running. I have concerns about durability, and I say potential that anything that isn't maintained can have durability issues. It doesn't effectively reduce humidity. It can some, but once that core has the humidity, or if it's raining outside and it's humid inside, then you're not going to get any exchange. Your operating costs are higher. We saw on the fan efficiency chart that it is much less and required less efficiency. And it's less effective at exchanging energy in normal climate zones. And I say normal, it's probably not worded, it's like I maybe need to, but it's like oversizing your AC for 100-degree days. You're going to have some, but on the days that you aren't or you're not, you don't need to have that oversizing. You're not going to have an exchange that's really going to justify, in my opinion, to make that additional investment. And here's another way to do balanced. You could do and that's a QFAM there, one of mine. You could add that. You could make that have that communicate with a vent-a-hood, or you could have it communicate with an exhaust fan. And when I say communicate, that could bring on that, or that could bring on each other, and you could have the exhaust out, and then you could bring the fresh air in. Strength of that, it's efficient. Fresh air supply, air in, stale air out. Removes harmful pollutants like NO2, PM 2.5. Can mitigate some temperature and humidity. It's a cost-effective solution, especially if you're already installing a range hood. It does require the ASHRAE 62.2 range hood if used, and Air King does make one of those. Make the one that is 62.2 approved, and needs an interlock connection. It will need something to make those talk to each other, which those kits are available. Why are we concerned about that air that's up at the top? I mean, we're not up there. That's not where we live. But this is what happens whenever stale air sits or resides at the top, and there is no movement. There is no air that is brought across it, even if it's humid air. And these are not old homes. This is again where you see the mold. See the mold here. You can see where a lot of the moisture is. All right, exhaust fans, new construction. That would be considered a pretty good application. You're exhausting out. They use mastic, which is not probably the best thing to use, but just overall, that's a pretty good installation. Here's some exhaust fan hood termination locations. Here's a nice hood mounted on the wall. It will have which isn't shown, it's got a flapper in there. Nice hood, good capture, good exhaust, good area to be able to get the air out. Here's a round exhaust termination coming through the soffit. And here's another one that's coming along through the soffit. And then I showed one, this is one that has a screen on it that you need, but you see these in more applications now than you are as much as you are, more than you do the metal. And here's the way that we used to exhaust fan duct terminations, which you could see and still see in some municipalities. It's not a good way to do it. We always thought doing it that way was really a more professional, but then if you think about it now, where's that hot, humid air going? It's going right into the insulation. So turning it up is probably better. We just didn't want to fill it up with insulation. Here's a triple exhaust fan venting. They got them all together and used a black tie, which I thought was a picture worth including. Here's where they did not cut off the duct. Probably works, but you do need to be mindful is that is not going to have good airflow or exhaust. It'd have been just as easy to just pull that and cut that off and not have it bunched up like that. You don't need it in a pretzel. And here's another one that I included. This is an existing house, but whenever you have a really, really tight house or a loose house, is that that's where you have problems. That's where you have issues. If you don't have that vented properly, you're depending on heat rising. There is no push coming off that water heater to get that exhaust or to have the vent operate correctly. You're depending on the heat rising and going out. Well, that heat can't rise right there because you're coming back down. And they did a really nice job of flaring the end of that pipe and putting it over the vent riser coming off the water heater. And backdraft venting, whenever you see one combined, which we don't see that a lot, but it's just how that effect is and how that is a negative. And you see that you don't need any help with backdrafting down. That is a bigger vent going into smaller. It can technically go in the wrong direction. So that's one thing, again, that it needs to be on there. It doesn't need to be misaligned. And I personally don't like to see them combined. And here's one I found that is a dryer vent that was never vented. It was just stubbed in the attic. That's lint on the inside of that deck. And that insulation was pink. That's lint. Lint is a highly flammable product, or it's highly flammable. And that is a fire hazard and a bad thing. And I have personally found that more than once. And it is not, it's really scary and it's not good. Cooktop venting. Again, it's becoming so much more critical and important. Here's one that's vented, smooth pipe, elbows. You could have used another piece of tape, but overall, a good venting solution. Here's one with metal flex for a microwave that did pass code. They had a manufacturer's letter that said that is approved application. So the code official told me that had this. He said it did pass. So I didn't argue the point. I showed him the part of the code. He knew the part of the code, but he showed me he had a letter from the Metalflex vent guy that said that it works. So here's one that actually has some plastic or vinyl tubing. That is not approved. That is not a good application. Flex duct, flexible air conditioning duct is not a good method either. And the way that is joined up there at the top is just a lot of tape. So that is not a good application. That did not pass. And lastly, we've got the dryer venting. You see a lot of recessed dryer box. They are very good. You can actually get the dryer up closer, your appliances in the room. They're not sticking out. You can turn right up into it. So that is I thought that was a really good installation and a good application of the product. Venting, it's taped. But my last one is you never know what's behind the wall. So if you see after it's sheetrocked and you didn't see that, you would think that that was okay. But you see what they did to the framing and to just the way it's ducted, mostly the framing, how poor that is and how that'll affect the structure of the actual wall and of that room and maybe the house. Fresh air, is it a burden or essential? At some point, ventilation will go from a rule, a burden, a cost adder, or just a feature to a vital element that makes the house work right. Thank you very much. That's the end of my presentation.
Thank you, Tom. Fantastic. Just one comment. Duct test picture, and you admitted that was an old picture. Duct test picture shows improper reference hose placement and return being tested off of.
Okay.
Yeah, that's got to be a HERS rater. Yeah, it is. I see who's asking that. Yeah, good catch there, Donnie. I just real quick, and we are out of time, but just one. I guess if just a little bit of your thoughts as far as, in my opinion, the new ASHRAE 62.2 formula is, how do I say it nicely? Grossly overventilates homes. If you were truly getting that CFM, it seems to me like it's based on a worst case scenario. And I always, I show the chart just out of the IRC, that shows 4 to 5 bedrooms, and it's got the bedrooms across the top and the square footage down the left. And I'd just be curious to get your comments on, I show that chart and talk about my wife and I in our 4-bedroom, 2,700 square foot house where we don't cook and we go in and out all day. We open the windows. We dry 3 loads of laundry a day. Well, we need, per that chart, 75 CFM of continuous fresh air. Well, a little old couple in a 4-bedroom, 2,700 square foot home that have 9 cats and 3 dogs and fry 3 meals a day and don't turn on the vent-a-hood, never open a window, do 1 load of laundry a week, they also need 75 CFM of continuous fresh air in their house. So I just to elaborate a little bit on, in your opinion, where you think those CFM rates are they based on worst case scenario on a big, even if a house is testing at 3 air changes an hour, but if it's a 5,000 square foot house, a 6,000 square foot house, if it's right at 3 air changes an hour, are you getting enough natural infiltration as it is? Just your general thoughts about the new formula on 62.2, the required CFM rates in general.
Oh, sure. I do have an opinion about that. And I do go to the committee meetings. I'm not on the 62.2 committee, but I do go to them and spend 2 days. And it is becoming apparent to me from listening to everyone, and I agree with this, is that we're ventilating too much, because the term was continually used, that's the minimal, you can't ventilate too much. Well, obviously you can. I think that lifestyle and the type of people is hard to put into a formula. It's been based on bedrooms and square footage forever. Some of the people that wrote that, like Joe Stebrick, he says that he doesn't follow that formula or that that application or that chart anymore. He doesn't like it. There's people on the committee that still support it. I don't think that people were considered, obviously, whenever that it was written. It was about bedrooms and square footage. Of course, it's associated with how many people are in each bedroom. I see the committee trying to look at different ways to reduce that ventilation rate. Since they took away any kind of assumed credit, that's why it went from 1 CFM per 100 square feet to 3, because they weren't assuming anything. Let's go test the house and see how it tests, and then we're able to look at that differently and say, okay, we don't need as much. Where you can reduce it, but that's hard to determine. The consideration is that if you put they're looking at putting this in ASHRAE standard, is that if you've got a MERV 11 filter installed in your HVAC system, you have a cleaner house, so you don't need to ventilate as much. They're looking at giving that a 20% credit. But there's no guarantee that the person's going to go back with a MERV 11. You go to Home Depot, and that doesn't make them bad. They're just going to buy what fits their not only finances but their lifestyle. They don't want to go with a MERV 11, so that's an issue there. But I think that it's been very aggressive. And as I'm answering your question, I think we ventilate too much. That's the reason I like my strategy. Is that if conditions outside are too hot, too cold, too wet, too dry, is that let's ventilate less during that period. Let's bring in fresh air. Let's bring in 15 minutes worth of fresh air within that hour, but let's do it in short increments. Let's let the house have an opportunity to deal with it. Or let's be able to set that CFM of continuous ventilation at what we consider to be a reasonable rate. You have the opportunity to change that. Now, there are people that obviously live as the code and the ASHRAE standards live and die, that they don't sway off of anything, but I see doing consulting and working with people, different projects, is that it winds up being too much, especially in, let's say, Austin, San Antonio, that had so much moisture this last year, so much rain. Normal operation of ventilation systems, HVAC, wasn't enough, and they have a lot of moisture problems.
Well, I could not agree more. I think it's about 3 times what it is. Now, for that little old couple with 9 cats and 3 dogs, I think it's about appropriate. But for the vast majority of folks, I could not agree with you anymore that it does grossly overventilate. I do have just one more comment. I know we're a few minutes over, but I don't think you plugged your smart strategy enough, Tom. So I do want to give your fan one plug and just a comment to the code officials out there. Me personally, as a recovering building official, I always felt it was my job, not only to enforce the code, because the code is the crummiest house you can build by law, right? But to also give my builders helpful advice. And I think we saw on the poll earlier that the majority of builders are using the controller with the air handler motor. And just a couple of comments on that strategy. Yeah, it's only $80 for that controller, but when you go up in the attic, that controller's got 3 dials on it, square footage, CFM, number of bedrooms. I guarantee you go up on a final inspection, all 3 of those dials are turned all the way to the left because of that problem you mentioned. Hey, honey, I heard the air conditioner kick on. You walk over to the thermostat and it's off, so they don't ever want that thing kicking on. And the bigger problem to me is if you run air follows the path of least resistance, right? You run a 6-inch duct to that controlled damper to your return plenum. Well, also coming into that return plenum is a 16-inch duct running to a 20 by 25 in the hall, 3 8-inch ducts running to 12 by 12s in the bedroom. Well, when that air handler is running, how much of a trickle of air is coming in that 6-inch duct? Air is going to be coming through that 16 and those 3 8s at I mean, I would have guessed there's very, very little coming in that way. So I think literally for under $200 more or a couple $100 more, having the only way to ventilate a home in Texas, in my opinion, is with some sort of smart strategy. When that outdoor air is too hot and too humid, you don't want to be bringing it in. And so having that controller and that sensor, and then that fan that's only pulling a fraction of the watts, ducting that separately, or not ducting it separately, but the same setup that most builders are using now, but just having, whether it's QFresh or one of your competitors, my main point being, it has to be some sort of smart ventilation. It has to sense, oh, I've got a humidistat tied into my thermostat. Well, by the time your thermostat's reading it's too moist in your house, it's too late. You want to be capturing that air is too moist at the source. And if you have that fan ducted to your 6-inch duct, well, you know that you're getting that true CFM because that's the only place it's pulling from. And I just think you've got a fantastic solution. And I just, again, encourage code officials that feel like they're partners with their builders the way I did, to just have a conversation with their builder about their current ventilation strategy and give them some ideas and options. And certainly you guys can see Tom's contact information there. Give them Tom's contact information. Have them contact me. It doesn't have to be the QFresh. I personally, I'm building my own house. That's what I would go with. But it does. For just a couple $100 more, you have, if you have any, you want to do your homeowners right, you have to have some sort of smart inline air sensor for your ventilation strategy. So that was my comment. And I really appreciate you joining us this morning, Tom. I figured you might agree. Great presentation. We are about 15 minutes over, so I do want to go ahead and shut it off. Any last comments, concerns, or anything else, Tom?
Yeah, no, not really. Just in that it's becoming so much more critical, and with the weather patterns we have now, it's not getting any better in the way of bringing in moisture and for our area, and the heat. In that you just have to be smart about it, and that's obviously what we try to do.
Couldn't agree more. Thanks, everyone, for joining us so much this morning. Murrell will send out a course evaluation. If you want ICC CEUs, just fill out that evaluation. All the instructions will be in the email. Thanks for joining us, everyone, this morning. You guys have a great day, and we'll talk to you in 2 weeks for the next Speakers Bureau webinar. Thanks a lot, Tom. Talk to you later.